Here we go. Same as question 51, except the garbage truck and the Corvette stick together. Oh, this can happen. Alright, so we remember the mass of the truck was 8 times 10 to the third, 8,000 kilograms. We remember its initial velocity was 12 meters per second south. Well, south positive again. The mass of the Corvette was 2,000, 2 times 10 to the third kilograms. Its initial velocity, the truck, was 0 meters per second. Now they stick together. Determine the final velocity of the truck and Corvette combination. Now, you see the word collision. You hear about cars combining. They give you masses and velocities. That's the giveaway. It's a P before equals P after. So before, after, you put the equals here, you don't put the equals here, it doesn't matter. Anyway, what does matter is that you're actually doing conservation of momentum. P before equals P after. So the momentum before is contained in the truck plus the Corvette. The momentum after is contained in the truck plus the Corvette, except what we're thinking now, since they collide and stick together, this somehow is going to be combined, and we'll see in a moment how to do that. Okay, so before the collision, well, we know it's the mass of the truck times its velocity, plus, now it's okay right now. Some of you may say, well look, the Corvette's at rest. Let me just hash that, it's a 0. I'm okay with that actually. Mass of Corvette, velocity of Corvette. I'll write it the full way, but mass of the truck, velocity of the truck, plus mass Corvette, velocity Corvette after. So if you realize right now, I'll do some different color, doing green. If you realize right now, there's certain things you could realize immediately. Number one, you could realize that this is nothing, just cross it out and don't do it. Number two, you could also realize over here that this actually is going to be a combined mass of the truck plus Corvette times the velocity of the truck Corvette. So we'll see how that plays out in a moment. Let's keep going. So the truck before is 8,000 kilograms. The velocity before is 12 plus, we know this is 0, equals. Here, the key is recognizing that when they combine, they have the same velocity. They stick together, so they move together. And so really what you're dealing with is the truck's mass plus the Corvette's mass, since they're together, moving off at one final velocity of the truck Corvette. Now it's a fairly easy problem to do. 0 is gone, don't worry about that. 8 times 12, again, you have your 96,000 kilogram meters per second, the same as the original initial momentum. 8,000 and 2,000 is 10,000 times the velocity of the truck Corvette. So, finish this off, divide 10,000, divide 10,000, 1, 2, 3, and that'll put a decimal on here. So the final truck Corvette velocity is 9.6 meters per second, being that they're stuck together. It's positive, so it's still south. This makes sense, by the way, if you compare it. When the truck hits the Corvette, sends the Corvette off on its own, that small mass experiences a big acceleration during the hit, and it ends up at 24 meters per second. When the truck grabs the Corvette, the two of them, that's a big mass, will experience a smaller acceleration up to this 9.6 meters per second as they move along. All right, last one. Flip question 52. The Corvette traveling at 12 meters per second south. All right, now we're going to have the Corvette hit the truck. So, mass of the Corvette, 2,000 kilograms. Mass of the truck, 8,000 kilograms. Okay. Now the velocity initial of the Corvette is 12 meters per second south again, south positive. Velocity initial of the truck is 0. And after the collision, the garbage truck, the velocity final of the truck is 6 meters per second south. So south we call positive, so we'll leave that positive. And finally, determine the final velocity of the Corvette. Now, these do tend to telegraph, they do tend to give away what's going on here. Before, after. And so what's going on here is masses, velocities, collision. This is a P before equals P after again. P before, equals P after. So, momentum of the truck plus the momentum of the Corvette before they hit is going to be the momentum of the truck plus the momentum of the Corvette after they hit. Mass truck, velocity truck plus mass vet, velocity Corvette. Mass truck, mass Corvette, velocity Corvette after. Now at this point, some of you again may realize, look, the truck is not moving initially, so that's going to be 0. Good. All right, let's fill in some numbers. Here we go. What's the Corvette? 2,000 kilograms times its velocity, which is 12 meters per second, equals the truck is 8,000 kilograms times its velocity, so it actually continues south 6 meters per second, plus the Corvette's 2,000 times its final velocity, whatever that's going to be. So if we run these real quick, 2 times 12 is 24, is 24,000 kilogram meters per second. 6 times 8 is 48,000, plus 2,000 the Corvette after the hit. Alright, so what do? Subtract 48,000. Don't make your math teachers cry here. This comes out to negative 24,000 equals 2,000 velocity Corvette. Divide both sides. 0, 0, 0. 2 into 24 makes 12. The final velocity of the Corvette is negative 12 meters per second, which is 12 meters per second north now, not south. Okay, so that's a rough review of what you'll see on the two-body momentum problems. There are others still. One that I didn't cover on here, but it is on the homework, is the football player problem, where, let's draw it down here. You have one player running this way with a velocity, and you have a second player running this way with a velocity. And so they may ask about what happens, they stick together or something else. Just beware that if we call, let's say, this velocity, maybe call this way positive, then V1 will be positive, but V2 will be negative. So you got to be very careful when you plug that in. 55 is a nice question. Try to figure that out for fun.